now it's your turn to graph a quadratic function by algebraically finding the vertex, horizontal intercepts, vertical intercept, and some other key information about the function. If you've not attempted this question on your own already, please pause the video, complete this in your lecture notes packet, then return to the video to check your work. So for the function g, where g of x equals x squared minus 2x minus 3, we're going to complete each of the following one at a time. In part A, we need to algebraically find the vertex. To find the vertex, we first need to find the x-coordinate of the vertex. To find the x-coordinate, we use the formula x equals the opposite of b over 2a. For this particular function, the x-coordinate of the vertex would equal the opposite of negative 2 all over 2 times 1. Simplifying in the numerator, the opposite of negative 2 is 2. In the denominator, 2 times 1 is 2, and so overall we have 2 over 2, and 2 over 2 simplifies to 1. To find the y-coordinate of the vertex, we then need to substitute in this x value and for the x's in our function. So our y-coordinate is going to be g of 1. G of 1 indicates again that we're going to substitute 1 in for all of the x's, so g of 1 will be 1 squared minus 2 times 1 minus 3. 1 squared is 1, and negative 2 times 1 is negative 2, so 1 minus 2 minus 3 is negative 4. So we know the vertex will be located at the point 1, negative 4. In part B, we need to algebraically find the horizontal intercepts. We need to remember that the horizontal intercepts are the same thing as the x-intercepts. And we find the x-intercepts by setting the y-coordinate equal to 0. When we're dealing with a function, the way we say we're going to set the y-coordinate equal to 0 is to set the function equal to 0. So we need to set g of x equal to 0. So in setting g of x equal to 0, we will have the equation x squared minus 2x minus 3 equals 0. To solve this equation, since we're not told what method to use, we're free to make our choice. Looking at this particular equation, I can see that I can factor it fairly quickly. What multiplies to make negative 3 and adds to make negative 2? Well, negative 3 times a positive 1 equals negative 3, and negative 3 plus 1 equals negative 2. So this will factor as x minus 3 times x plus 1. And now that it's factored, we can separate this using the zero factor theorem. One of these two factors has to be equal to 0 for the product to equal 0. So either x minus 3 equals 0, or x plus 1 equals 0. If x minus 3 equals 0, then I can add 3 to both sides of the equation to find that x equals 3. If x plus 1 equals 0, then I can subtract 1 from both sides of the equation to find that x equals negative 1. So the horizontal intercepts are the points 3, 0 and negative 1, 0. In part C, we need to algebraically find the vertical intercept. Again, the vertical intercept is another way to say the y-intercept. And to find the y-intercept, we need to set the x-coordinate equal to 0. In terms of this function, we set x equal to 0 by evaluating g of 0. To evaluate g of 0, we substitute 0 in for all of the x's, and so g of 0 equals 0 squared minus 2 times 0 minus 3. The first two terms are actually equal to 0, so they cancel out and we're left with negative 3. So g of 0 equals negative 3, and we have the vertical intercept at the point 0, negative 3. In part D, we need to identify whether the parabola will open up or down by looking at the first term that is x squared, or a 1x squared. Since our a value is 1 and that a value is positive, we therefore know this will open up. In part E, we need to answer the question, what is the domain of the function? Well, the domain of every quadratic function is all real numbers, so we can state this domain as either the double bar r, or as the interval from negative infinity to positive infinity. In part F, we need to answer the question, what is the range of g? The range of g is all the y values that will be used by this graph, or by this function. Since we know the vertex has a y value of negative 4, and the parabola opens up from that point, we know that negative 4 will be the least y value used by this function. So the range will never get less than negative 4, but we also know because it opens up and it doesn't ever stop moving upward, the range will never top out. So we will describe the range as negative 4 to infinity. We'll put a bracket on the negative 4 because negative 4 is actually included as a y value, so it does actually get that low. But on the infinity, we will always use parentheses. We use parentheses because infinity is not a number. We can never actually get to that value. And in part g, we need to answer the question, what is the axis of symmetry of this function g? The axis of symmetry is the vertical line that goes through the vertex. So it will be the vertical line x equals 1. While we won't usually draw this on the graph, we will use its symmetry to help us find other points on the graph when we get to the point where we're graphing this. And finally, in part h, we need to graph y equals g of x. To begin graphing this function, we'll always start by drawing in the axes using a ruler. We'll make sure we label the x and the y-axes appropriately. We'll be sure to put arrows on at least the positive ends of the axes. And we'll put a scale on the axes. Looking at all of the coordinates that we have, all of the coordinates have x and y values between -6 and 6, so we can use a scale of 1, 2, 3 on each axis. Now that the graph is set up, we can begin plotting the points that we have found. In part A, we found that the vertex was located at 1, -4. In part B, we found that the x-intercepts were at -1, 0, and over at 3, 0. In part C, we found that the vertical intercept was at 0, -3. In part G, we stated that the axis of symmetry was the vertical line x equal to 1, so we'll momentarily draw that in to use the symmetry to help us graph this function. And with that axis of symmetry drawn in, we can use it to plot one more point on our graph. Since we know 0, -3 is on the left side of the axis of symmetry, we know there has to be a point mirrored on the other side, over at 2, -3. So one of the main uses we can make of the axis of symmetry is to mirror any point that's on the left or the right to the other side. At this point, we have enough information to complete a basic sketch of this graph, so we'll do it by connecting the dots in as smooth a way as possible. Again, remember, as you graph parabolas, do not use your ruler to graph the parabola itself. You want to make the parabola as smooth as possible and making sure you hit all the points that you've graphed. And keeping in mind we want this to be as symmetrical as possible, we'll try to mirror exactly what we've done on the right side over on the left side. And for having done this without a computer, this is a pretty decent sketch. We will remove the axis of symmetry from the graph, and there we have the sketch of the graph of the function y equals g of x, where g of x equals x squared minus 2x minus 3. Typically, when you algebraically find the vertex, horizontal intercepts, and vertical intercept, you will typically have 4 points that you have calculated. You can obtain a 5th point by using the symmetry of the parabola itself.